Hi everyone, my name is Denis Potapov. I will use a short video to demonstrate the technique of repeated integration. I will demonstrate this technique on this example. This is the example of triple integral, and this triple integral is taken. This triple integral is taken over this domain. I will use this example to demonstrate the technique of triple integration. First, have a look at this short video which shows you the domain omega itself. Okay, now when we have more or less good understanding what the domain omega is about in 3D, we can see how to produce a repeated integral which corresponds to the initial triple integral. Basically, the process is very simple because the domain omega is already given in the right description, in the right form. All you do is you just take these inequalities and you copy these inequalities in the right positions. For instance, this inequality, you take the left-hand side and the right-hand side of this inequality and you copy as the lower and the upper limit for the outer integration, x integration. You say you do the same with this. You do absolutely the same with the second inequality. You take the left-hand side and the right-hand side of the second inequality and you copy this as the lower and the upper limit for the next integration. And that's the y integration because the inequality was inequality for the variable y. The last, you do the same thing with the last inequality. You copy the bounds of this inequality here, and that is the z integration, the innermost integration in this version of the repeated integral. The next short video shows you the visualization for this particular order of the repeated integral. If you look closely at the video, you will see this little ball which runs from the bottom to the top, and that's the ball which represents the innermost integration, the z integration. Then you see this rod which moves from back and forth. That's the representation for y integration, and then you see the plane, the cut through the volume which runs from left to right, and that's the representation for x integration. Okay, the actual evaluation of this repeated integral is given in the file which I have just uploaded on the Blackboard. If you're interested, you can check that. In this video, now I will show you the alternative repeated integral which corresponds to the same triple integral we given at the outset. Right, so this time I'll make the repeated integral which has this order of integration. Y integration will be the outer integration, x integration, will be the next integration in order, and z will be the innermost, yet it will be the innermost integration. Here already you see the limits of this particular order of integration. Before we can realize how we produce these limits, we have to understand the connection of this new description of the same volume omega with my initial description for the volume omega. Let's just try to analyze that. Okay, now at this stage we want to see the connection between the description for the omega volume here, which we given in our problem, with this new description for the omega volume down here. The connection is relatively simple. All we did here is just we copied the inequalities in a smart way from this upper box down to this lower box. For instance, this inequality y bigger or equal than 0, we just copied from here. Or this inequality y doesn't exceed 2. This one is a bit more tricky. For instance, this one came from a combination of two inequalities in the upper box, this inequality and this one. Indeed, y here doesn't exceed, this inequality says that y doesn't exceed x, this inequality says that x doesn't exceed 2, which if you combine these together and you drop x out, you will realize that it will say to you that the y doesn't exceed 2. Now the next inequality in this new description for the volume omega, this is just again some smart copying of the inequalities from the first description. For instance, this one came from here, and x doesn't exceed 2 obviously came from here. And the last inequality is trivially just a repetition of the one we had before. And this is it. As soon as you describe the domain omega in this new way, you can now produce the corresponding repeated integral, the outer inequality. Sorry, the first inequality goes as the limits for the outer integration, and this time it is integration with respect to the y. Next inequality goes as the limits for the next integration, and that's the integration for the x. And the final inequality still produce the innermost z integration, here. Okay, that's how we can produce an alternative repeated integral which corresponds to the same triple integral we started with. The next short video will show you will visualize for you the repeated integration in this order. Again, you will see this little ball which runs from the bottom to the top. That's the representation for the z integral. Next, you will see this little rod which runs from left to right, and that's the x integration. And finally, the outer integration, that's where this is plane which cuts through the volume, which runs back and forth. And that is the y integration, the outer integration in this version of the repeated integral. Okay, finally, I have another way to repeat the same triple integral for you, and that's the hardest out of these three. And that's the repetition, where the z integration is said to be the outer integration. Look at let me scroll this down a little bit. Here it is. Here's the result we're aiming at. Here z is the outer integration. Y is the next integration in order, and this x will be the innermost integration in this repeated integral. Of course, in order to produce this repeated integral, I mean I produced this integral already, but in order to see how I produced the limits here, how I found these limits for each of the individual integral, we have to see the connection between this new description for the same volume omega. We have to see the connection of this new description for the same volume omega with my initial description for the omega we given in the problem. Right, we will see this in a second. Yeah, I will load the page. Okay. In this final part of this demonstration, I will produce yet another repeated integral which corresponds to the same triple integral. The same triple integral we started with, this triple integral. This time, I would like to make my z is the outer. I would like to make my z the outer integration in my repeated integral. Well, in order to do that, I have to take this initial description of the omega volume and show you that this omega volume can also be described like this. The key observation in this description is this equivalence which is sitting here. Let's just first look at this equivalence. What does it say? It takes the z inequality in the initial description and solves this inequality with respect to the x. Here we go. Here's the inequality in terms of x. Now, having these two having this inequality in the alternative form like this, having this inequality in terms of x, now we can explain how this lower box, the lowest box, this new description for the omega, was produced for the initial description of the omega. Some of the things are relatively easy. For instance, z bigger than 0, bigger or equal than 0, just came from here. And the z doesn't exceed 4. This is a bit trickier. This second inequality here came from this part combined, you'll be surprised, combined with this part. Because when x here takes the extreme value 0, x takes the extreme value here, z will take the value 4, and that's the biggest possible value for z in the domain omega. Now the rest is not so hard either. For instance, y bigger or equal than 0 obviously came from this inequality. And this one, this is again a little bit trickier. This one is a combination of two inequalities. One of them is this one, which says y doesn't exceed x, and the other one is this one. If you combine these two, the first one says y doesn't exceed x, the second one says x doesn't exceed root 4 times z. If you drop the x out of this, you will realize it will give you y doesn't exceed root 4 times z. And that's how we obtained this inequality. The final one, it's almost done. The left side, of course, came from here, and the right side is just a copy of this inequality. And that's a description of omega, the same volume omega we've been repeating the third time now. It's the same volume omega, but now the repetition goes with the z in the first place, y in the second place, and x in the last place. And now, when we have this new description, we just copy the limits of this description, limits of this inequality, bounds of this inequality, into the corresponding positions into the corresponding positions of my integration. That gives me the z integration here. That gives me the y integration here. And that gives me the x integration, the innermost integration I have is the x integration, and the y which I highlighted now. And this is it. That's the third version, the third alternative you can use to iterate the same triple integral. The last clip of my video will show you the integration in this way, in this order. Here you will see the ball runs from left and right. That's the x integration, the innermost integration. Then the rod runs back and forth. That's y integration. And finally the plane, which cuts through the volume, runs from the bottom to the top. And that's the outer z integration. This is it. Thank you. This was Denis Potapov. See you next time.